All right, just to recap what we learned on Friday, when we are multiplying a monomial, so one term, by a polynomial, so something with many terms, we are simply going to multiply the monomial to each term in the polynomial. So for terms with exponents, we're going to use we're going to use the product rule, which is right up here. In case you've forgotten, the product rule is that if you multiply two numbers with the same base with different exponents, you actually add the exponents. So just to give you a little idea, I'm going to regroup. This is all multiplying. Every single thing in these two terms are multiplying together. It's actually like one big term. So I'm just going to rearrange it so the things that are alike. So like 3 and 12, those are both constants. I'm going to put them next to each other. X squared and x, they have the same base, so I'm going to put them next to each other. And y have the same base, so I'm going to put them next to each other. Now it lets me kind of imagine like 3 different sets of multiplication. I'm just going to do 3 times 12, which is 36. And then x squared times x, that's like x times x times x, so that's really 3 x's. What I'm doing, though, is I'm imagining this invisible exponent of 1 there. Using the product rule, I would add 2 plus 1 to get 3. Okay, again, and then for the y's, that has an invisible 1, that has an invisible 1. So altogether, how many y's are multiplying? There's 2 of them, so it's y squared. So this is my answer. So I'm going to go ahead and just talk through each of these problems below. If you feel like you understand the concept, you can move on, but I will walk you through each of these examples. So we'll start. Remember, we are going to multiply my monomial by every single term. So we have to start by distributing. That's going to give me 5m times m squared. Oops, I keep pushing the wrong button. m squared plus 5m times negative 10m plus 5m times negative 4. Again, I'm going to imagine this is how many m squares do I have? It's like having just 1. If there's not a coefficient out in front. But what I'm doing is I'm multiplying 5 times 1 and m times m squared. Okay, that's what I'm thinking about. And I'm not going to keep writing that every single time. I think as we get better and better at this, we should be able to just see that we're going to multiply the constants. But just so that we're really clear, this is going to be 5 times negative 10 and m times m. And this last term will be 5 times negative 4 and then times m. Okay, so once I've chunked that, and if it helps you to actually write out each of the parts reassociated, so moving them next to each other, the like parts, then definitely do that. It can help you prevent errors. So 5 times 1 is just 5, and m times m squared altogether, that makes 3 m's, because remember, there's this invisible 1. So 1 plus 2 gives me a total of 3 m's multiplying in that term. 5 times negative 10 is going to give me overall negative 50. So I'm going to write minus 50, and then m times m gives me m squared. Again, if you don't remember, there's little ones. So that's like doing 1 plus 1 for our product rule. Remember, the product rule tells me you just add up their exponents. All right, and then my last term, I'm going to have 5 times negative 4, so that's going to be a negative and 20. And then this m, there's not another m multiplying by it. It's kind of just by itself, so it's not going to change. It's just going to stay m. My last step, I might want to check and make sure that I'm in standard form, which means highest exponent to lowest. So this goes 3, 2, and then 1. So this is standard form, and I'm done. All right, I'm going to move a little faster through the rest of these examples, but come back and watch number 1 again if you need a more detailed version. I always start by distributing, so I'm going to have 4x squared times 2x plus negative 4x squared times negative 7 plus negative 4x squared times 3x squared. Okay, so then when I multiply, I am just going to kind of watch, instead of rewriting it, I'm going to watch those are the same, these are the same. I'm chunking together the parts of each term that can be multiplied together. So I have to either be a constant or I have to have, sorry, that one's blue. Oh, this one doesn't have an x, this one doesn't have an x part to it, so that's okay. That means x squared will just not change. And there's an x part and there's an x part. If I'd had another letter there, I could have focused on that, but I'm going to do negative 4 times 2 gives me negative 8, and x squared times 2x gives me a total of x to the third. So it's got a little 1 there. Okay, the next one I'm going to have negative 4 times negative 7. So negative times a negative will be a positive 28. X squared doesn't have anything to multiply by, so it will just stay x squared. And then I'm going to multiply my negative 4 times 3 is negative 12. And x squared times x squared gives me x to the fourth. Now this one I can see that my highest degree term is this one right here because it has an exponent 4. So I'm going to rewrite this in standard form, and it will be negative 12x to the fourth. The next highest term is the 3 and then the 2. So I'll write it in that order. Minus 8x to the third plus 28x squared. And that is my final answer. All right, number 3. I'm going to have negative 3x to the fourth. I'm going to distribute to each of the terms. Plus negative 3. Oh, let's see. I forgot to write what it was multiplying by. Got ahead of myself. At 6x squared y squared plus negative 3x to the fourth times negative 12xy. And then negative 3x to the fourth times 16. Okay, so I'm again going to think about, here are constant terms. These both have x for their base. This one has y for its base. So I'm just going to make sure that I'm always putting together the things that are alike. So that's going to be a constant term. And then those are an x term. This is a y all by itself, so that y won't change. And then again, constant. And then there's nothing to combine the x with. All right, so once I kind of have this picture of what's going to combine, I'm going to do negative 3 times 6 gives me negative 18. X to the fourth times x squared. I'm going to do 4 plus 2. So altogether I have x to the sixth. And then since there's nothing else to multiply by y squared, it will still just be y squared. For the next term, negative 3 times negative 12 is positive 36. X to the fourth times x to the 1 makes altogether x to the fifth. And then that y doesn't have anything else to multiply by, so it will stay y. And then my last term, negative 3 times 16, that's going to be a negative 48. And then that x to the fourth won't change. Okay, so now I'm looking at, is this in standard form? I want to examine each term individually, and I can see I have a term here. There's 1 term, 2 terms, 3 terms. Within each term, if there is more than 1 variable, so in this case I have, I have x and I have a y, I'm actually going to add up their total degree. So this x has a degree 6, y is a degree 2. So altogether, this is a degree 8 term. This term right here has a 5 and a 1. So altogether, that is a degree 6. And then the last term is degree 4. So this is written in standard form. I just wanted to make sure you recognize when we have more than one letter, our degree is going to be those exponents on each letter, each variable added together. Okay, next example. Let's see. I'm going to multiply c squared d to negative 2c to the fourth plus c squared d times negative cd plus c squared d times 3d cubed. All right, so I'm going to combine this one. Notice the coefficient, if no coefficient is listed, this is a coefficient of 1. So when I multiply this coefficient by any of the other coefficients, it's always just going to stay, it's going to be 1 times whatever that other coefficient is. So in this case, it will be negative 2. And then, let's see, I have this c squared and that's c to the fourth. So altogether, I have c to the sixth. And then d doesn't have anything with it, so that's just going to stay d. And the next one, this has a coefficient of 1. This has a coefficient of negative 1. So altogether, I'm going to have minus just 1, but I don't have to write it. I've got a c times a c to the 1, so that's going to be c to the third, and a d times d gives me d squared. And then on my last one, this term has a coefficient of 1, and that one has a coefficient of 3. So that will be 3c squared doesn't have anything to multiply by. D times d to the third makes altogether 4 d's multiplying. Okay, and I want to check my, if I'm in standard form, this one will have 6 plus 1, so a degree 7. 3 plus 2 would be a degree 5, and 2 plus 4 would be degree 6. So I actually need to rearrange this. This one was 2c to the 6d, that's degree 7. But the last term, 3c squared d to the fourth minus c cubed d squared. So this is my final answer. All right, next one. This one looks a little scary because there's a fraction, but this little, I can tell the 12 and 8 are going to divide nicely with that 4, so I'm not too afraid. Okay, I'm going to, this time I'm going to think about it without rewriting. In each of these other examples, I rewrote the distribution. I'm going to see if we can do it without rewriting it. I'm just going to think about it one term at a time. I'm going to do 5x times 7, negative 7x. That's going to give me negative 35 from the coefficients and x squared from x times x. Now I'm going to do 5x times 3. That's going to give me 15x. Okay, and then I'm going to take this and distribute it. Now remember, we are going to bring that negative with us when we multiply. So negative 3/4 times 12. I'm going to just show you down here. Here's 3/4 times 12. That's going to give me 36 over 4, because remember, we multiply across the tops, across the bottoms, and that will be 36 divided by 4 will give me negative 9. So when I multiply negative 3/4 x by 12, I'm going to get minus 9x. My denominator kind of canceled away. And then when I multiply the next one, if I do negative 3/4 times 8, that will be negative 24 over 4. And I know that that will just equal negative 6. So that will be minus 6. And then I have to remember I'm doing x times x squared. So that's a total of x cubed. Now in this example, I end up with these two terms right here that are both x terms. And so before I say my answer is final, I want to combine any like terms. And those ones are alike because they have base of x, exponent of 1. So I'll have negative 35x squared plus 6x, right? 15 minus 9 will be 6, plus 6x cubed. Erase our work down here so we've got space. This is not in standard forms. I want to rewrite the highest degree term. This has a degree 3, degree 2, degree 1. So I'm going to write it in that order. 6x to the third minus 35x squared plus 6x. That is my final answer. All right, we're getting there, guys. So And if at some point you feel like you're feeling pretty confident, you can go ahead and move on to the next video. Okay, so I'm going to do negative 2x times x cubed. So I'm going to have negative 2 for my coefficient and x to the 4th. Okay, then I will do negative 2x times negative 6x squared, which will be negative 2 times negative 6 is positive 12. And x times x squared gives me x to the 3rd. And then negative 2x times 6 gives me minus 12x. This plus 4x is just to the 3rd is just kind of sitting there. It's not multiplying by anything. It's just adding in there. But I have to be careful because this negative sign means I'm subtracting everything in the parentheses. So I've got to make sure I distribute that negative. Okay, if there's a negative outside of parentheses, you have to make sure that you distribute it. Minus 10x. Okay, so now what I want to look for is I'm going to look for any like terms that I have. And I have these two that have x to the 3rds. And I have these two that have just an x term. There's no other term with an x squared, and there's no other term with an x to the 4th. So those ones aren't going to change. But I am going to combine. My highest degree term is that x to the 4th. So it will be the first term. Then I'm going to combine this 12x to the 3rd plus 4x to the 3rd. So altogether that will give me 16x to the 3rd. And then my x squared term will come next. Then I've got, let's see, this negative 12x minus 10x. So that will be minus 22x. Okay, these problems are getting, the multiplication isn't changing, it's just we're now adding in an extra step that we may need to distribute or combine like terms before we're done. All right, 2 more examples. Write the area of a trapezoid as a simplified expression. So you probably need to remember that the area of a trapezoid, it's the height divided by 2 times base 1 plus base 2. So I gotta identify this right here, this is the height of my trapezoid. And this is the first base. And this is the second base. So I'm going to just plug things in. So I know I'm going to have the height. So that's 3x divided by 2. And I'm going to multiply it by my base 1, which is 8x squared minus 12. Plus 4x squared plus 2x. Okay, so before I even start multiplying, I can see right here that these are like terms. So I'm just going to save myself one step of distributing by combining like terms to begin with. So that will give me 3x over 2, and that will be a total of 12x squared. Let's see, plus, I'm going to write it in descending order, 2x, and then minus 12. So I've got my highest degree term here, next highest and lowest degree term. So I just rearranged those. Okay, so now we got to do some multiplication. So I'm going to do, now remember this 2 on the denominator, that's like saying 12 divided by 2. So that's really, 12 divided by 2 is 6, and then 6 times 3 gives me 18. And x times x squared will give me 18x to the 3rd. When I multiply my 3 halves times this 2, 2 divided by 2 is just 1. So I'm going to have 3 times 1, which will just be 3, and x times x, which is x squared. And then for my last one, this 12 divided by 2 is going to be negative, so negative 12 divided by 2 gives me negative 6, and then when I do 3 times negative 6, I will get minus 18, and an x will just be there. So that is my simplified answer. I am going through this multiplication fast, so you don't, but if this multiplication is a struggle, absolutely put that into your calculator. You could just type right in 3 halves times 12. So 3 divided 2 times 12. It will give you these answers. So don't let your math facts hold you back. Use your tools appropriately, and you can figure out these numbers by yourself. Even if you can't do it in your head, that's fine. All right, our last one. We are writing the area of the shaded region as a simplified expression. So my whole area, if I want to find the whole area of that big gray rectangle, I would do length times width, right? So 5x times 9x plus 4. But I need to subtract away this white part. There's kind of a hole in my rectangle. So I'm going to subtract 2x times 3x minus 5, because I want, this is the area of the shaded region, this is the area of the white part, so I'm going to subtract it. Okay, so then again, we're going to just multiply. 5x times 9 gives 9x will be 45x squared, and then 5x times 4 will be 20x. Okay, and then I'm going to distribute over here. Remember that sign comes with you. So I'm going to do negative 2x times 3x. So negative 2 times negative 3 will be negative 6. X times x will be x squared. And then negative 2x times negative 5 will be minus 10x. I'm going to look for like terms to combine. So here are x squared terms. And here are x terms. So that's going to be, 45 minus 6 should be 39x squared, and 20 minus 10 will be plus 10x. So that would be the area of the shaded part. Okay, that was a lot of practice. Hopefully that gives you enough examples. I did it to varying degrees of writing out the work. Do what works for you. If it really helps you to write out this step where you put the things that are the coefficients together and the variables together, absolutely write that step. If you're feeling confident, you can kind of just do the distribution. Your call, but there you go.